I take this slide 5, these are the key concepts that you must understand and be able to explain, to discuss, and so on. So as I explained, you need to be familiar with synchronous versus asynchronous, why synchronous have issues, what is the benefit of using asynchronous programming, which is basically responsiveness in the client side and better scalability on the server side. Then you need to understand how it is really done in JavaScript. So JavaScript is a single-threaded, but it's still being able to do this asynchronous programming style thanks to this, what is known as JavaScript event loop. I kind of explained it before. So what happens is, in JavaScript, we have only one thread, which has a stack that has the functions that has been called before. So anything that is asynchronous, it runs on another thread pool that you as a programmer, you don't have access to. Then let's say you made the fetch request. So the fetch will be done not in the main thread, will be done in another thread. Automatically, you don't handle that. And then when the results are ready, what happens is they will go to the queue. So the queue will have the results of function that you called before. And when the queue will watch the stack, if there is nothing running, it will schedule the results, schedule the callbacks. Remember that you do callbacks or promises. So basically one way, of course, of implementing asynchronous is using callback functions. So you make a function call asynchronously. When the results are ready, your callback function will be called. So when the results are ready, the callback gets queued, because when the stack is busy, you cannot kind of say, like get out of the stack, I have something to run. You have to kind of wait and keep waiting until the stack there is nothing going on, and then you basically execute the callback function. So that's basically how it works. And this is the same event loop that is on the client side and the server side. So the browser has this event loop implementation, and Node.js also has the event loop implementation. So anything asynchronous, such as reading files or getting data from another web API, you never do synchronously. You do it asynchronously, and then you register. When you make a call, you register a callback and say, okay, when the results are back, please call me. Now, when the callback is scheduled in this queue until there is a chance in the stack and then it gets executed. So you can, if you have time, you can watch this video. It really, really explains it very well, what this event loop is. Okay, with animation and so on. Now, once you understand synchronous versus asynchronous, why we do asynchronous, and then you kind of understand in high level the mechanisms internally JavaScript uses to do asynchronous programming, then you have to get familiar with the programming styles, how you do it as a programmer. So the traditional way are callbacks. Then callbacks have this problem of callback hell, where the code is basically growing vertically like horizontally like a pyramid. Both vertically, but more problem. The code growing vertically, it's not a problem. That's what we are familiar with. But when it starts growing vertically and horizontally, that is a problematic. It's very hard to understand, very hard to debug and maintain. So the next evolution of doing asynchronous programming is promises. And a promise, you need to be familiar what this promise is, how it is done. But semantically, or in terms of meaning, is the same meaning as the promise we have in plain English. So promise something future value. So when you call a function, it does not give you a value. It gives you a promise. And then you kind of hold on onto that promise, and then at a certain stage, that promise will either be fulfilled or rejected. Okay, so if you remember, when you call a function that return you a promise, what you do, you do then to handle the fulfillment of the promise, and you do catch to handle the rejection or if there is an exception. So it's just a way of avoiding this callback hell. So your code again is not growing horizontally, it's growing vertically. If you have to chain these promises, you just keep chaining them using then. And those are growing vertically, yes? Now, it's not bad, it's a good evolution, much better than callbacks. And then came this async and await, which is in the latest version of JavaScript, ES7. And this is async and await. We are back to synchronous looking code. The code looks like it is a synchronous code, but it's really asynchronous. The only thing is in any time I make an asynchronous call, what do? In front of the function call, I put the keyword async. And now if I do that function where I use async, I have to mark it as a, sorry. Now basically when I make a function call, what I will mark it with? Await, okay? Which means it's kind of is just, you can think of it as a simplification of promises, but it's still in the, like internally, kind of using the same concept or same primitives as promises. So let me repeat again. So for any asynchronous call, it looks like synchronous. The only difference is in front of it we use this keyword await. So the runtime knows that this is an asynchronous call. Now as soon as you put await on any of the function calls, that function should have an async. So the caller of that function kind of will know that this is an asynchronous function. So as soon as you call an asynchronous function, that function becomes also asynchronous. And then we are back to kind of very synchronous looking code, and we don't have any more that complexity of using callbacks or promises. So that's basically the idea. And in here, just go back, look at some examples, see how a callback-based code looks like, and how when we rewrite it as promises, how it looks like, and when we rewrite it as asynchronous, how it looks like. And so you'll be able to kind of rewrite from one style to another. So basically, that's what these asynchronous JavaScript programming is all about. Okay, so that's basically the first one. Second one is the MVC-based JavaScript web app. So in here, what we have studied, and very important to really go back and revise. And by the way, these are the reason why I included this, because these are the fundamentals. Any web developer is supposed to really know very well and be able to explain and be able to really be very familiar with them. That's why I'm going back to them to kind of get you to revise them. Okay, now, as a web programmer, you must understand HTTP. There is no escape. It's a very critical protocol that you need to understand. And here, you need to understand what are the HTTP verbs, what are the difference between them, and also the major headers. Not all of them, but just the major ones, like status, which could be 200 OK, 404 not found, and so on. And also, like, let's say, accept, content type, those very basic headers that you as developer need to kind of know by heart, because you need them. You use them in your own programming when you are doing the programming. Okay, that's the first skill and first knowledge that you should be well equipped and you should well understand it very well. Then, when you start building an application, you need to follow certain architecture or certain way of organizing your code, because slowly it will get complex. Even in simple applications that we saw in this course, the code start to get complex quite quickly. So to master that complexity and be on top of it and not let us give us hard time is to keep things organized and to really follow very strict guidelines in terms of how you organize your code. So one way to do it is to use some architecture. The most famous ones are model view controller architecture. You must understand this one. Although it is kind of coming out of fashion and there are better ways of doing things, but still it still has its place. Yes, please.
Can you write like what we understand?
Yes, of course.
Explain what we understand.
Yeah.
Not like this, like.
No, explain what you understand. Explain what you understand. Of course, like, look, sometimes when you use a technical term, it will replace a couple of sentences that you want to say. For example, like, let's say when you say, let's say if I ask you the advantages of asynchronous code on the client on the server, if you say client, it gives you responsiveness, server, it improves scalability. This is very technical, very clear. You can explain it otherwise, it's fine. So the main thing is that you explain the concept or compare, whatever the question might be. Yeah, no problem. As long as the main concept is there, I will kind of look for it. For example, when I say the model, as long as I see that the model is doing some kind of computation, maybe some business logic, some data access, it's basically the actual functionality, where the actual functionality is implemented, that should be fine. The view provides the UI, it allows us to collect input and provide output. And the controller, it does the coordination. Yeah? So, and you have worked with this, so you are familiar with it. Now, the problem, here you should be able to compare both architectures that we have seen. It's very important. It's explicitly explained in many slides. So, for the MVC, it's a bit kind of unfair distribution of the load between the client and the server. You know, the clients these days are very powerful. Mobiles and desktops and laptops, very powerful. But this architecture is not making use of that powerful client-side, let's say, browser. Because the server side handles most of the stuff. Even it generates the view. Basically, the client just gets the HTML and renders it, maybe some JavaScript and so on. So the SPA came along to basically address this and have a much more fair distribution of the workload. So in SPA, like the actual routing, and by the way, the routing is done in the controller, the routing. Remember the routing? Like you say, when the user comes to this URL using this verb, this is the function you should call, or these are the set of functions you should call from the model. So the controller, part of the coordination is to decide where, when the request comes, who will handle it, how to handle it. So the server side does that. Now, when you move to the SPA, single page application, then what happened? We are pushing some of the responsibilities to the client. So for example, the view generation, when we generate the view, you know how we generate the view. We have some kind of template, we have some data, and then we kind of give the data to the template to generate the HTML. So traditionally, in most MVC, this is handled by the server side. In the SPA, it is fully handled by the client side, like something like Angular that you have worked with. So you have templates on the client side, and then what do we have on the server side? Do we really have like controllers or view generators? Sorry? Yeah, the repositories will remain there because the database will never move to the client because the client will not be able to handle it. It has other information they are not allowed to get. So repositories will be there. And then how do we make the repository functionalities accessible through the web? Web API, thank you. Also, we call them REST services or web API. So on the server side, there is no more, like let's say something like handlebar and handlebar engine. There is no more rendering on the client on the server side. There is only API that you call certain URL. Either if it's get, you get back JSON object. If it is post, you basically send in some kind of JSON object the server will process. So you can see here, no more kind of HTML flowing around, like basically exchange or sent to the client, except the first request. The first request will have what is called the shell page, the first page. Yes, that first page will have all the HTML and all the JavaScript. And then from that time onwards, that's why it's called single page application. There's only a single page, and then we keep loading components into the page. And then when we want to talk to the server, we only use an API, for example, fetch, to read and write from the server using web API. Yeah? So that basically, you need to be able to explain the difference between the two and the advantages, disadvantages of each one. Okay, now kind of one of the aspects here, one of the differences, of course, is, for example, the routing. The routing in MVC is done where? Where is the routing done? On the server side. And what about the view rendering or the view generation? On the server side with MVC. Yes. The view generation is typically done on the server side. Okay. Now the routing, the user interface routing or the navigation. Let's say the navigation between the page. We don't have pages. The navigation within the application in SPA is done on the client side. So, and what's the difference between the routing on the server side versus the routing on the client side? On the server side, what is the concept of a routing? Remember when you create a router on the server side, what are you doing?
We routed the verb and the link.
Yeah, the URL.
To a method or a function.
Oh, very good. To a function call. Okay. Now, on the client side, yes, there is the concept of a routing. What do we do in there?
Fetch by API.
No, that is not a route. That is basically communicating with the server side. That's the fetch API. But the routing on the client side, what do we do?
We associate the path with the component.
Sorry?
We associate the path with the component.
Yes, thank you very much. Yes. So, for example, in the case of Angular and in case of other application frameworks, so when you use SPA, typically your interface is made up of components, and then as the user interacts with the application, when they request certain URL, at the end when they click, they are requesting certain URL. And what you do, you take that URL and you map it to a component. So for example, let's say a small example from your yesterday's exam. So you might have, let's say, add task. So when you click add task, what the client is supposed to do, it's supposed to load the task editor component. And then let's say when you go and say, give me the tasks list, it's supposed to load the task list component. When you click on complete, it's supposed to load the complete task component. You see here? So the routing is kind of the same, but in here, it's more like loading a particular component to respond to certain, loading a component associated with certain URL. Now, when the component loads, it might go to the server side to get the data needed. And how it will go to the server side to get the data needed? Using something like fetch. And on the server side, what are we providing? API, web API or services, web services or REST services. So that's how it works. So we no longer, whenever we need to change the view and load another part of the view, we don't go to the server side, oh, please give us some HTML, how the task editor will look like, and we reload the whole page. So in MVC, typically we reload the whole page to refresh it. In SPA, we never reload the whole page. The page is loaded once, and then what do we reload, or what we load? Components. Yeah, and how this loading components in response to user actions. How is it done typically? Of course, you can use it by code, but you can also use it declaratively using the router component that comes with Angular. So there is this concept of routing. On the server side, it is more about mapping an HTTP verb and a URL to a function call. That's how the routing is done on the server side. On the client side, it is mainly used for managing the navigation or managing the user interface navigation, how the user jumps from one part of the application to another. Of course, we still have the URL concept there, but we don't have the verbs. It's just a partial URLs. And then we map them to components. So when the user goes to this particular link, this is the component that will be loaded. So you should be able to basically understand the routing and the difference between the two sides, the client side and the server side. Then you should be familiar with Web API. What do we mean with Web API? Also known as REST services. That's another name for them. So in here, it still uses HTTP to interact with the server side. But this time, instead of returning some kind of user interface elements like HTML, it returns JSON, typically. And it is more for program-to-program communication. So HTTP, initially when it was invented, it was more for human usage. People go to pages, and these pages have links, and they keep clicking those links and kind of doing what they need to do, exploring and getting to the documents they need. Now, with the REST services, it's more used for program-to-program communication. So let's say you have a component, like Angular components, which is a JavaScript program. Talking to the server side, you're just basically expecting a structured data like JSON. It doesn't need any formatting or any HTML. So that's basically the key idea. And the reason why this is very important is that in most applications you might have multiple user interfaces. So those of you, maybe some of you have done mobile application development, and you can see that you can have, for example, if you have a web API on the server side, you could have an Angular web app that runs on the browser and an Android applications that run on Android phone and iOS app. And they all use the same functionality provided by the server side. Because a web API, it uses a standard communication protocol and standard data format. Any of these platforms could very easily interact with this web API. Is clear? Okay. That's basically the idea of this. Of these slides, basically. So routing, you need to be familiar with it, and then maybe the concept of a middleware could be a good thing to know. Express, in Express there is this concept of a middleware, so which is basically a series of functions the request goes through before it reaches your function that you wrote to handle it. So it could be that we take the body, we extract the body from the request and make it easily available in a body property on the request. It's already converted to JSON, ready to use. That's the body parser. We might take every request and log it, put it in a file, so to know how many requests we get per hour, what users are accessing. So you can log everything that comes to your website. This is very important for you to know which pages are popular and so on. You could also, once you do this, you could also extract the authenticate and the user, make sure they are already logged in, and if they are logged in, they are authorized to do what they are trying to do. So all these are middleware that you can configure in your app, and when the request comes, it goes through those middlewares. If they make it through all these, then hopefully they will arrive to your code that you wrote yourself to handle the actual request. That's basically the idea. So this is the middleware, is some functions that sits between the request and the response. And the last function will be the one that you kind of write yourself. That's basically the idea. All right, so for REST services, these are the main ideas you should be familiar with. Nothing really fancy here. It's the same, it relies on the HTTP principles or the web principles. That every resource has an address, and every resource has the same interface. Same. We can use the get to get the resource, post to create new one, put to update it, and delete to delete it. Then a resource, when we request it, we can choose between different representations, like JSON or XML, although these days most of the applications, they accept JSON and return JSON. The other aspect we didn't really see, this is a bit more advanced, is that a resource can have links to other resources. We are familiar with this on the web, in the human web. When we get a page, you get a links to go to other pages. But even in the programmable web, you can get links. For example, let's say you place an order. You place an order to let's say Amazon as an example. So you get back a response object. It says your order has been no, sorry, you won't say this. This is not for human web. It will say, let's say order status pending, order number is this, and then it might give you some links. This is a link to cancel the order. This is a link to view the order status, and so on. So this is a definition of what a resource is. A resource has an address. We can interact with it using get, post, put, delete. We can get a representation of that resource in different formats, XML or JSON. And a resource can have a link to other resources. That's basically the idea of a REST service. Now, I think I gave you a lot of feedback on the naming of resources. Very important. When you name resources are nouns, not verbs. So you never put a verb in the URL. Because the verbs that we interact with the resources are already defined, which are, get, post, put, delete. In here, it's all nouns. And you can see it's got some kind of hierarchy that you can drill down into, go into the details. So for example, if you go here, you get all the books. If you give it this parameter, it gives you only the book with that ISBN. But if you're only interested to get only the authors, you can go and zoom in and get only the authors. So this is how you design, you design the URLs. So you don't come here and say for example, get books. It's not very good design. Or you can say here, get book by ID, or get book ID. Here just focus on nouns only. And some of the parts of the URL is really a parameter, it's a parameter. Even when you do the routing, if you remember, when you do the routing, you can mark part of the URL as a parameter using, I think, colon and the name. Yeah. And then you can access it through request.params and then the name. Yeah. Same thing here. You see here, I go classes. This will give me all the classes. And then I go to this particular class. It gives me all the information about this class. Let's say where is it located, what is its schedule, and the list of students. I can go and zoom in more and go into more like specific part of that resource and say only give me the students or only give me the instructor. So this is how we design the URLs. Okay, this you should be familiar with. The verbs, very important. And yeah, this is what I just explained. Really, if you think carefully, the resources are collections. Usually they have an S at the end. It's a plural. It's a collection of resources. And they have, you can address all of them, or one particular one, or even a sub-resource, or a sub-part of that resource. That's how you should picture it, and that's how you should design the URLs to reflect this. That's it. This is what you really need to understand here. Okay, the rest I didn't have time to go through and kind of cut what's, but we'll just kind of do it together very quickly. In here, what you should really understand is what's the role of JavaScript on the client side. So, and you should be able to give some scenarios where JavaScript can be used. So nothing here kind of syntactical or how you do things. It's more conceptual. Okay? So this is the minimum you should really be familiar with. Not how to do it necessarily, you already practiced this. But these are the typical things you can do with JavaScript on the client side. You can handle events when the user interacts with the page and clicks something or selects some elements in a drop-down and so on. You can go to the server side, fetch some data and update the page partially. So for example, you select a country, I go to the server, get the cities of that country and update the drop-down list. I can use it to validate the input, I can use it to do some simple computations on the client side. If somebody puts their date of birth, I can compute the age. I don't need to go all the way to the server to ask for the age. If there is some sorting, animation, it's done by JavaScript. And also asynchronous server calls. It's all done by JavaScript. So these are the main things you should be familiar with. More in terms of role or what you can do with it. Yeah, the concept of a DOM is very important to be familiar with it. The document object model, which is basically when the HTML page is loaded into the browser, it is accessible programmatically as a tree. And this tree data structure, we call it a DOM. And in JavaScript, really what you're doing in JavaScript, you're either selecting some elements from the page, you are updating their content, changing the style, listening to events, and so on. So really JavaScript, the main function of JavaScript on the client side is to do what? Is to manipulate the DOM. When I say what do we mean by manipulate? Remove some elements, hide them, show them, change their style, update their content, and so on. So these are the main concepts you should be familiar with. Now the how, of course you have already played with it. It's not critical here in terms of concept. Now the other thing you should be familiar with is what is known as AJAX, Asynchronous JavaScript and XML. It's an outdated name, but it's still there. So asynchronous server calls, we call them AJAX, asynchronous JavaScript and XML. XML is kind of out of fashion. Not many people are using it, but the name remained. So what the name implies here is that you go to the server side and you get some data from there asynchronously. We explained this before, like you never do it synchronously because between the client and the server, what there is between the client and the server? What's between them? How they are connected? Through a network, yes? And this network could experience delays, could experience congestions, and so on. So you don't want to be under the mercy of that network and get the user kind of blocked waiting for your reply. You do it asynchronously. In fact, in JavaScript or in the client side, you cannot call the server synchronously. By design, they put it there as asynchronous. Yeah. Okay. So that pattern of going to the server, getting some pieces of data to update, partially update the page, they give it an acronym or kind of a name, which is AJAX, asynchronous JavaScript and XML. And one way to do it, there are many APIs, but this is the latest way of doing it, using the fetch API. In here, you just need to be familiar with the concept, not the how. We have already done this so many times. But concept, this jQuery, don't worry about it. It's kind of getting out of fashion. JavaScript now is more standard than before. Before, every browser tries to kind of do things a bit differently, giving hard time to the developers. So they use jQuery to kind of unify the API. But these days, especially Microsoft, they have like made repentance, and they are more compliant with the standards. So your JavaScript more likely to work cross browsers. So you don't need an extra library. By the way, if you can avoid adding extra libraries, the better, of course, because you're reducing dependencies on things that doesn't belong to you. You don't have control over it. And if you remember, in terms of security, you have that like using component that has vulnerabilities. So if you can avoid it, if you can just use the plain JavaScript, do it. Unless if it's really hard and you will spend a lot of effort, then you can bring in a library to give you a help. But anything that is already nicely supported natively in the actual platform, use it and don't bring in more libraries. Okay. So that's what this is all about. Session management. Okay, there are here a lot of very interesting concepts that you should really understand. You should be able to distinguish between these three mechanisms. You should be very clear what's the difference between them. Difference between a session, a cookie, and a local storage. Here, very important to understand. So can someone try, maybe explain what's the difference between session, cookie, and local storage? And by the way, when I say the difference, as much as you can, try to find what is common and what's the difference. Although I kind of be lenient and accept definitions, but really, when I say what's the difference, is what is the common and what is the delta between them. Yes, please.
Both the cookies and the local storage are stored on the client side, but the session is stored on the server side.
Very good. And the three of them, what's the common between three of them?
They're temporary.
Temporary, yeah, kind of, yes. Although this can be stay there for a long time unless the user explicitly deletes it. But all of them, they help us manage state or keep some pieces of information that we care about in our application. That's the common denominator. That's the common thing between all of them. But they do it differently. Yes? So all of them, you have some piece of information. Let's say the user information, the user object. You need to know who the user is, what's their name, what's their first name, what's their last name. Because in every page you want to welcome them. You say, welcome Fulan or Fulana. You want to welcome them. Be like a bit more, make it more customizable. They don't feel like this is just a general page to everyone. You try to make it kind of customize it to their profile. Minimum is you greet them. Wherever they go, they know who I am. So that piece of information, which is the user object, or some pieces of the user object, you can keep them in any of these three. Yes? So this is the common denominator, is that you can use them to manage state. State is pieces of data that you care about and you want to keep. Yep. So session, what is the difference? This is the commonality, and you highlighted, very good, you highlighted another commonality. These two guys are on the client side, and the session is on the server side. Very good. What's the difference?
Session is more secure since it's stored in a database in the server. But the cookie, like sometimes you can get the cookie from the web browser.
Okay, very good.
The local storage as well.
Yes, very good, except that sessions are not in a database, by the way. The concept of a session is something that you need very frequently. For example, if you decide to store the user object in the session, where you will keep it? Session is usually kept in memory. Because every page I will tell you, welcome Fulana. I don't want to go back all the way to the database just to bring that piece of information. So I'll keep it in memory for performance reasons. Yes, you're absolutely right. Something sensitive, something's you don't want to be under the mercy of the user and keep it away from the curious and the malicious. You keep it on the server side. Very good. Yeah. Yes? And typically sessions, they are there forever. Usually you limit their time. Best practice is to have a limited, they stay there for a limited time. And here you need to understand why. For two reasons. The main reason is for the server to remain scalable. If we keep these sessions forever, and these sessions, remember, they stay in memory, then the server will run out of resources. Also, the longer we keep it, the longer we are exposed to attack. Somebody might somehow put their hand into the session ID and then they can hijack the whole session. But if we expire them quickly, we're reducing that risk or reducing the time frame of that risk. So cookies, for example, the difference between these two guys, cookies and local storage. Very fundamental differences. So because of the time, so cookies, they are auto sent to where they came from. So when you go to a website, automatically the cookies that came from that website will go back in the subsequent requests until they are expired, of course. But the local storage, it is stored in your locally, like kind of small key value database. It does not auto go back to where it came from. You have to explicitly read and write to it using JavaScript on the client side. Yeah? And here, storage is limited. Here, storage much bigger storage capacity. So these are the main concepts you should be familiar with. And also, what's the relationship between them? For example, here, a session, a cookie is used to communicate the session ID to the user, for example. So there are some relationships and there are some differences. So definitely you will get some questions here. Also, you should be familiar with the stateless and stateful. So which design is better, stateless or stateful? Stateless. You try not to remember things. Just do the work and forget and move on. Don't remember everything. But sometimes you have to. Sometimes you have to. When you have some complex interaction, a multi-step interaction to do something. This is very important. These slides definitely will get some questions on them. So please make sure you go through them very nicely. They are already summarized. I mean, only 21 slides covering the whole concept. Okay, Angular. Okay. Here, you'll be able to compare, as I mentioned, SPA with MVC, the key concepts in Angular, like, for example, how components interacts, maybe routing, the difference between routing on the client and routing on the server. These are the things I can think of here. Anything syntactical, you don't worry about it. It's just concepts. You focus on the concepts. Similar style that we went through and discussed the other slides. Okay. Same thing here. Maybe you should be familiar with the mean stack and why it is important, why we are not using here a relational database, maybe what is the difference between relational and something like MongoDB. These things you should be very familiar with. Here it is explained like document-oriented versus a relational database. Then the syntactical stuff, you don't need to worry about it. So here, the main thing here is the main stack, and also being familiar with the MongoDB, document-oriented database versus a relational database, the motivation behind it, why this framework or this stack is getting very popular, and being able to explain it. The other syntax stuff, don't worry too much about it. Java EE. Okay. In here, for example, being able to differentiate between interacting using JDBC and interacting using JPA. Also, in Java EE, the main thing you should be familiar with here, it relies heavily on annotations. It comes to some classes and add some annotations to do something, to either make a class an entity, or to make a class a service. You use annotations to do it. You should be familiar with what is Java EE, what is the difference between Java EE and Java SE, and the difference between JDBC and JPA. Okay, in JDBC, you go and interact with the database, you get some kind of result set, which is a tabular data format. And you, as a developer, you need to convert them to objects. Yeah? While JPA, you're dealing with objects. When you make a query, you get a list of objects. You don't need to worry about how to convert from a tabular structure to objects. And also, when you have an object, you don't need to convert it to an insert statement. You just take an object and kind of push it and persist it in the database. The JPA will generate the SQL to do it for you. So you just need to be familiar with kind of the philosophy or the key ideas behind Java EE, and the difference between these things. What else? For unit testing, you just need to be familiar what is unit testing, what are the different types of unit tests, what are the different types of tests, integration testing, user acceptance testing, and so on. Nothing to do with the syntax, okay? And the philosophy of unit testing, or testing in general, that you have some expected results, you have some actual, and then you compare the actual with the expected. And testing is all about establishing evidence that your application works, and not just providing programmatic evidence. So you write a program to basically establish evidence that your program works, by comparing the actual and the expected. Now in here, definitely you will get some questions on web security. You have this top 10. You should be really familiar with them, being able to explain them, being able to give example scenarios of attacks, being able to discuss how they can be mitigated, how they can be avoided. So we spent like maybe 3 sessions or so. Please go through them. It's quite straightforward and very important. Minimal vulnerabilities you as web developer need to be really familiar with. So basically this is what this will be around. So similar style, I will be going through these and basically extracting some of the questions from this, similar to what we just did today. Okay, thank you very much. Assalamu alaikum.